Good morning, students. Myself, Ashagila Devi, Assistant Professor in Rovini College of Engineering and Technology. In today's class, we are going to study convolutional neural networks, commonly known as CNN, which are the core component of deep learning. CNN are especially designed to work in image and visual data. They are widely used in applications such as face recognition, medical image analysis, self driving cars, and object detection. So, by the end of this session, you will learn or you'll understand why CNN are needed, how CNN architecture works, and popular CNN models used in real world applications. So, the need for CNN. So, traditional neural networks do not work efficiently with images because images have high dimensionality and spatial informations. So, CNN overcome this problem by learning local patterns, reducing the number of parameters, and preserving the spatial relationship in images. So, this makes the CNN more powerful and efficient for visual tasks. So next we are going to see about the CNN architecture overview. Let us now look at the basic architecture of a CNN. A CNN consists of the following layers: input layer, convolutional layer, pooling layer, and fully connected layer. So each layer has a specific function in processing image data. So the functions of CNN layer, first is the convolutional layer. The convolutional layer is one of the most important layer in CNN. So this layer applies the filters on the input images, extract the features such as edges, shapes and textures, and produces the feature maps. So these filters are learned automatically during the training using backpropagation and gradient descent. So next about the pooling layer, where the purpose of the pooling layer is to reduce the spatial size and the feature map, and reduces the computation, and it prevents overfitting. So the common pooling methods include max pooling and average pooling. So the pooling helps in CNN for focusing the most important features. And when we discuss about the fully connected layers, the fully connected layer is similar to the traditional neural network layers. It takes the flattened features from the previous layers, it performs a classification and produces the final output. So this layers decides which class of the input image belongs to. And in learning in CNN, the CNN learns using backpropagation, gradient descent, and optimization. So the network adjusts its filter weights to minimize the classification error. So next, and the important thing is we are going to discuss about the popular CNN architectures. So then some important CNN architectures are: first, LANET architecture. The LANET architecture was introduced by Yan Lee in 1998. It was designed for handwritten digit recognition. LANET is simple, efficient, and is suitable for smaller data sets. And next is the AlexNet architecture. It is introduced by Kiske Sky, and it's won the ImageNet 2012 award. It consists of 5 convolutional layers, 3 fully connected layers. It introduced ReLU activation and dropout for regulations. It has around 60 million parameters. And about ISFNet architecture, ISFNet is improved by AlexNet. It's modified the filter size by adjusting the strides. It introduced deconvolutional to visualize the learned features. And next is GoogleNet. The GoogleNet won ImageNet 2014 award. It uses inception modules which apply multiple filter sizes in parallel. It also uses 1x1 convolution, global average pooling, and it reduces the parameters significantly. And next is VGNet architecture. VGNet architecture was developed by Oxford University. It uses very deep architecture, that is 16 to 19 layers, simple 3x3 convolutional filters. So VGNet is widely used for transfer learning. Next is RSNet architecture. It is introduced for residual connections to solve the vanishing gradient problems. It enabled the training of very deep neural networks such as ResNet 50, ResNet 101, and ResNet 152. Next is mobile nets. The mobile nets are lightweight CNN designed for mobile and embedded devices. They are depth-wise separable. They use depth-wise separable convolutions. They are fast, memory efficient, and suitable for real-time applications. Next is GoogleNet Deep Dream. The Deep Dream is a creative applications of CNN. It visualizes the features learned by CNN and generate the dreamlike images. It helps to help us to understand what CNN learn internally. So when we discuss about, or when we summarize this today's class, the CNN are specially neural networks for image processing. They consist of convolution, pooling, and fully connected layers. Several CNN architecture has evolved to improve the performance and efficiency. So in the next class, we'll see the applications on the numerical examples of CNN. Thank you. Happy learning.